In this video, we're going to take a look at listing outcomes. Now, the goal for today, and I want you to write this down in your notes, is to find possible outcomes of an event by making a tree diagram or by multiplying. We're going to look at both strategies. So this is the goal that I want you to write down in your notes for this video. So we're going to take a look at this problem, and I just want you to follow along as I do this. It says, Sarah packed jeans, brown pants, and 3 shirts, red, blue, and white, signifying the 3 different colors. How many different pant shirt outfits can she wear? Now, if I were to just try to solve this problem in my head, it would be a little difficult. Okay, however, if I want to make a tree diagram, it'll make it a little bit easier for me. So if I just simply write J for jeans and BP for brown pants, now what I can see is I can easily start making a tree diagram to help me see the different combinations. Okay, so with the jeans, if Sarah wore a red shirt with jeans, she could also wear blue shirt, then also a white shirt. Okay, now as far as the brown pants, if Sarah wore the 3 different combinations with the brown pants, you can see the red shirt, the blue shirt, and then also the white shirt. Okay, so we can see there are 1, 2, 3, 4, 5, 6 different combinations. Okay, that does answer our question. So how many different pant shirt outfits can she wear? We could say that Sarah could wear 6 different pant shirt outfits. Now, another way to solve this problem is you take the 2 different types of pants, the jeans and the brown pants that Sarah's able to wear, which would be 2, and then you can multiply by the different shirts she could wear, which would be 3 shirts. So you could take 2 times 3, which would give you 6, still giving you the same answer that the tree diagram would have given you as well. Okay, the tree diagram may be a little bit easier for you to actually see the answer. This multiplication strategy may be a little abstract. In other words, it may be a little bit difficult to see all the different combinations. But that is another strategy that you can use, 2 times 3 or using the tree diagram. Both of it will give you the same answer. Now I want you to get out your notes and your pencil, and I want you to follow along and do this problem with me. Okay, now we're taking a look at spinner C and spinner D there at the bottom. So we're going to use these 2 spinners for all 3 questions. Okay, now first of all it says, what are the possible outcomes if you spin spinner C? Okay, so it's pretty obvious here. Spinner C could have 1 or 2 for an outcome. So we're just kind of establishing some basic rules with these 2 spinners. Now spinner D, you can see the outcomes could be 1, 2, 3, or 4. Now just going back on a previous video, each of these numbers has an equally likely chance to land on a certain number. Same with spinner C. Okay, so we've pretty much seen the different outcomes. Now we're going to take a look at the next question. It says, make a tree diagram to show the sample space for spinning both spinners at the same time. Okay, so what I can do is I can see that spinner C, I'm going to start with the number 1 for spinner C, and then also spinner D at the same time. What I will do is I'll make a tree diagram so I could land on a 1 with spinner C, I can land on 1 with spinner D. 1 with spinner C, 2 with spinner D, 1 with spinner C, 3 with spinner C, and tree diagram's getting a little rickety here. 1 with spinner C and 4 with spinner C. Okay, now if I'm looking at spinner D and spinner C, okay, if I had a 2 on spinner C, I could also have a 1 on spinner D, 2 on spinner D, 3 on spinner D. Now you can see just making this type of tree diagram really makes it concrete. We can really visualize all their different outcomes. Okay, so we did our tree diagram, represent the 1 representing what we would spin on spinner C, the 2 representing a 2 on spinner C. And you can see all the different outcomes for spinner D. Now, they're asking us, your chances of spinning a 1 on spinner C and a 2 on spinner D is blank out of blank. They're trying to have us figure out what's the probability or what's the outcome you think would happen. Now we can see, before we even move into this, we can see that there are 8 possibilities here. Okay, 4 different possibilities if you land on spinner 1. I'm sorry, 1 on spinner C. 4 different possibilities if you land with a 2 on spinner C. Okay, when you spin with spinner D. Now, another way that we could figure this problem out is we could just have 2 representing the outcomes on spinner C. We could multiply that by 4 representing the outcomes on spinner D. So 2 times 4 would give me 8. Got a little bit ahead of myself there. Okay, so 8 possible outcomes that we can see. Okay, now your chances of spinning a 1 on spinner C, which is right here, and a 2 on spinner D, which we have right here, okay, is blank out of blank. Now what we can see, there's one outcome out of 8 that we had here. So your chance of doing this would actually be only 1 out of 8. So that is a not likely event. However, it is equally likely to spin anything else, like a 1 on spinner C and a 4 on spinner D, and so on. Okay, now we're going to take a look at another problem together. It says the coach is trying to decide in what order Jane, Pete, and Lou will run a relay race. Complete the tree diagram below to show the sample space. Okay, so some of this is already completed for us. All right, so we have, first of all, we need to look at each person. Okay, so we have Jane, we have Lou already given here for the first. However, we don't want to forget Pete, so we're just going to put Pete right here. I do want you to complete this problem in your notes with me as well. Okay, so we can have Jane going first. Okay, now Pete could go second, or Lou could go second. Okay, now third, we could either have Lou go third if Jane went first. I'm just going to use their first initials. Or Pete could go first, or third. I apologize. Okay, so we could have Jane going first, Pete or Lou going second, Lou or Pete going third. The next one, we could have Pete going first. We could have Jane or Lou going second. And then we could have Lou or Jane going third. Actually, I need to erase these two. I'm going to put it underneath the third column here. L and P. There we go. Okay, now if Lou went first, we could have either Jane or Pete going second, or Pete or Jane going third. Okay, so we've listed all the different types of possibilities. You can see how a tree diagram really makes it visual for all of us. Okay, so it's asking us how many possible outcomes are there in the sample space. So we can see that there are actually 6 different outcomes that are possible. 6 different outcomes. Now it says after the first runner is chosen, how many choices are there for the second runner? So you can see we chose Jane for the first runner. There's only 3 people, so obviously there are only just 2 choices after the first runner is chosen. Okay, so once again, you can see how this tree diagram really makes it visual for all of us in solving these types of problems. Okay, this is going to be the last problem that we do. However, we are still going to continue to work on these together. It's important just to see all the different ways to solve these types of problems and all the different problems that you could actually encounter. Okay, so we're going to take a look at the spinner, the coin, and then also the number cube. Now, the number cube goes to numbers 1, 2, 3, 4, 5, 6. Okay, now it's asking us what are the possible outcomes if you spin the spinner. Okay, so if you spin the spinner, we're going to establish some background or some important things. You can see there's a blue, so we'll say B. There's a red, green, and yellow. Okay, so those are the different outcomes. Now, tossing the coin, pretty obvious here. Heads and tails for the different outcomes. Now, knowing this, it's telling us to make a tree diagram to list the possible outcomes when spinning the spinner and tossing the coin. Okay, so what I'm going to do is I'm going to take my two possible results for tossing the coin. I'm going to have a heads, okay, and then I'm going to have my tails. Now what I'm going to do is make a tree diagram showing me the possible outcomes. It may be tricky just trying to figure out in my head, but a tree diagram, as I have said, makes it very visual for you. Okay, so if I spin a heads, I can also land on a blue with my spinner. Think flip ahead. Can't really spin ahead. I can also have a heads and a green. Okay, I can also have a heads and a yellow. And I can also have a heads along with the red. So 1, 2, 3, 4 different outcomes. Now for my tails, I'm just going to move this down here. For my tails, once again, you can see exactly what I did with my heads. I can have a blue, a tails and a blue, tails and a green, tails and a yellow, and a tails and a red. Okay, so these are all the different outcomes that are possible if I'm flipping my coin and spinning the spinner. You can see I have 8 different outcomes that are possible. Or if I want to figure out the total amount of outcomes, I can see there's 2 different outcomes with my coin, 4 different outcomes with my spinner. So with that, what I can do is just even multiply 2 times 4. So that gives me 8 total outcomes. Okay, that if you're trying to figure out the total outcomes, that could be a way that you would want to do it. Or if you're trying to find all the different possibilities, you can see how a tree diagram really helps us be organized with this process. Now I want you to answer this last question all by yourself. It says make a tree diagram to show the outcomes for spinning the spinner and tossing the dice. And I want you to make this tree diagram by pausing the video, complete it in your notes, so when you're finished you can press play and I'll have the diagram for you. Pause the video now. Okay, so here's the tree diagram that you should have. Okay, I don't expect you to have all the different colors like I have. However, you should have the blue color with the possibility of 1, 2, 3, 4, 5, 6, green 1, 2, 3, 4, 5, 6, yellow 1, 2, 3, 4, 5, 6, also red 1, 2, 3, 4, 5, 6. Now they don't need to be in this exact order of color. Make sure just all the tree diagrams have the color along with the possible outcomes. Now if we were trying to figure out the total amount of outcomes that you could have for this event, you could just take the 4 colors of the spinner and multiply it by the 6 outcomes, which would give you 24 different outcomes that are possible. Okay, so this is how you use a tree diagram and also multiplication to figure out different scenarios and list outcomes. If you have any questions about this concept, please come and see me.